Alright, in today's video, we are going to give an introduction to series. Specifically, we're going to look at whether or not series converge or diverge. Now, if you don't know what series are, series tend to be a very difficult topic for beginning calculus students to understand. And if you do know what series are, then you know exactly what I'm talking about. And the big question we ask ourselves when we're dealing with series is, does the series converge or diverge? And that's what we're asking today. Does this A sub n converge? Now, how can we figure that? What does it mean for it to converge? Well, if the series converges, then it must be approaching some value as we go to infinity. Now, let's see what this value, if this function approaches a certain value as we go to infinity. Now, let's say we wanted to check out what a sub 1 is equal to, right? Let's say we wanted to know what a sub 1 is equal to. A sub 1. Well, we would just plug in 1 for all of our n, right? So negative 1 to the 1 plus 1 power, that's just 1 over n, which is 1. So we have 1 over 1 is equal to 1, right? Now, what if we had a sub 2? Okay, let's see. 2 plus 1 is 3. So negative 1 to the third power is going to be negative 1 over 2. So we get negative 1/2. What if we do a sub 3? I'm going to skip the part where I speak this out loud to you because this is just plugging in numbers. This is going to give us 1/3. And you might see a pattern developing, right? A sub 4, negative 1/4. A sub 5 is going to be 1/5. A sub 6 equals negative 1/6. So is there something that we can see right now? We can see that as n gets larger and larger and larger, we seem to be oscillating between our positives and negatives, but more importantly, we are approaching 0, right? So, we are moving towards infinity, and we're approaching a number. Now, this sounds like something familiar, something easy that we know. That's what a limit is. Let's say the limit as n approaches infinity, and in this case, n will be starting at 1 of our function a sub n, right? And then we're going to write this as the limit as n approaches infinity of, let's see, we have negative 1 to the n plus 1 power over n is going to be equal to 0. And the last I checked, 0 is a value, right? This is something. We have figured out that the series does approach some value as n gets larger and larger and larger. So in this case, we would say that the series converges, right? And say we didn't approach some value, then in that case we would say the series diverges. Now, I want to look at a couple practice problems, right? So let's move on to something else. Let's look at a sub n in this case, right? Now, we know that we can use our limit as n approaches infinity to help solve this case. Now, let's think for a second. Let's look at the degrees of our denominator and our numerator for a second, right? In the numerator, we have n squared, and in the denominator, we have n squared, right? And n squared is clearly going to grow much, much faster than n, right? It's an exponential function, right? If n is equal to 1, n squared is 1. But if n is equal to 5, n squared is equal to 25. If n is equal to 10, n squared is 100. So clearly, n squared grows a lot larger than everything else. So it's almost like these numbers become irrelevant, right? Who cares? Who cares about those numbers when you have this gigantic weight right next to them that they don't really affect as we get super large n values, right? And we can say the same in the denominator. This plus 2 is not making a difference. So all we have here is n squared over n squared as we approach infinity, right? And we can say, well, we have n squared over n squared. The last I checked, that's just 1. So, does this series converge? Yes, we would say the series does converge because as n approaches infinity, as n gets larger and larger, we approach a value for our series. We approach 1, right? Now, what about this next, a sub n, right? Again, we can just look at these degrees in the numerator and the denominator, right? This is reminiscent of looking for asymptotes with limits, if you remember that. Let's look at our degree. We have n squared in the numerator, and we have an n to the first power in our denominator. So this is clearly going to grow much, much faster than our denominator is going to, right? But the thing is, in this case, we're not really approaching any one value. So we would say that this series diverges. So hopefully you understand at least the basic difference between convergence and divergence. In future videos, we're going to look at how we can use summations and partial sums to tell whether or not a series converges or diverges. So if you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.